A pleasant day, STEM learners. This is Sir Peter, your statistics and probability teacher. For today's discussion, we will have a review of the mean, the variance, and the standard deviation. So at this end of this video lesson, you should be able to recall and illustrate the mean, the variance, and the standard deviation. So during your junior high school mathematics, your teacher already told you about these three concepts. So I hope you were able to recall what is the definition of a mean, a variance, and a standard deviation. Do you remember this one? The measures of central tendency. So during our grade 7, we have learned that the mean is the average value. The median is the middle value, while the mode is the most common or the most frequent value. Let's take this one as an example. A group of STEM researchers asked the respondents on a survey on the perception of senior high school students about the effectiveness of online class. The survey adopted a 5-point Likert scale where 5 means strongly agree and 1 means strongly disagree. So a 3 response would mean a neutral 1 and 4 means agree, while 2 means disagree. So find the mean, the median, and the mode of the responses in the survey. So reflected here are the responses. We have 5, 3, 4, 4, 3, 4, 4, 3, 4, 4, respectively. So first is we need to find the mean. To represent the mean, we use the symbol x bar, which means the sample mean. So you simply get the summation of the responses. So we add 5 plus 3 plus 4 plus 4 plus 3 plus 4 plus 4 plus 3 plus 4 plus 4. And the summation will be 38. Divide it by the total number of observation, which is 10. So the mean now is 3.8. So it means that the average response of the respondents in the survey is 3.8. Now, how about the median? To get the middle value, we need to arrange our set of data from least to greatest or in ascending order. So first, we will list 3 neutral responses. Then we have 6 agree responses. And lastly, we have 1 strongly agree response. So all in all, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since our data is even number, we will get the 2 middle values, which is the 5th element and the 6th element. Then we get the average, 4 plus 4 divided by 2. So therefore, the median is still 4. And obviously, the most common value or the most common response is 4. So therefore, that is our mode. So I hope you were able to recall the definition of the 3 measures of central tendency. Now, let us proceed to the second part of our review. Let's have the measures of variability or the spread. So during your grade 7 and grade 8, your teacher were able to discuss with you the range, the mean deviation, the variance, and the standard deviation. But among these measurements, it is the variance and the standard deviation which we usually use for statistical interpretation. And specifically, we use the standard deviation to define how far are we from the center or from the measure of central tendency. So the farther it goes from the center, therefore the larger the value of the standard deviation. While the closer it goes from the center, the smaller the value of the standard deviation. Because the standard deviation gives us an idea about the variability, whether the responses are homogeneous or heterogeneous, or whether they are how spread your data is. Are they closely related with each other or are they far from each other? So that is what the standard deviation gives us. Now, what is the importance of the variance? We cannot get the standard deviation without the presence of the variance, because getting the square root of the variance would give us the value of the standard deviation. Observe these two sets of data that we have. So for data number 1, we have Carl's, Wade, Bea, Boy, Mary, and Joyce. So the mean weight of the particular students is 56 kilograms, or this is the average weight. Well, for the second data, we have Mina, Ara, Kat, John, and Roy respectively. And observe their weights. We have 48, 52, 62, 53, and 65 kilograms respectively. But still, we obtained the same mean, having different sets of data. Now, since their averages are different, observe their variances. The variance here on the first set is 2 kilograms, while the variance here is 41.2. So, notice that the weights on data 1 are closely related to each other. So, this is more homogeneous. So, the variability is they are close to each other. While in here, the lowest value is 48 and the highest value is 65. So therefore, there is more variability on this set. That is why observe the computed standard deviation. So how did we obtain the standard deviation? We simply get the square root of 2 and the square root of 41.2 kilograms. And then we get 1.41 and 6.42. So as I've told you, the closer your responses are, then the smaller the standard deviation is. And in here, the farther your data are, the higher the value of the standard deviation. So this has more variability and this has less variability as to its standard deviation. So I know that during your grade 10 mathematics, you were also asked to find some measures of position. You have the quartile, the decile, and the percentile. So it describes what part of the distribution are below or above your set of data. So we can also consider this one as a measure of rank or a measure of position. Now, among all the three measures, these are the common measurements that we use for data interpretation in research. We have the mean, the variance, and the standard deviation. So understanding these three concepts will lead us to understanding also the mean, the variance, and the standard deviation of a discrete probability distribution. Always remember that in statistics, we use sampling to describe a data. So we do not study the entire population, but we just considered sample data out of the population. So to summarize the symbols and for your familiarity for the next lesson, when we pertain to a sample mean, we use the symbol x bar. For the sample variance, we use the symbol s squared. And since the variance is the standard deviation is the square root of the variance, therefore we use the symbol s. Now, when we pertain to the entire population, or it could be the discrete probability distribution, which is equivalent to the entire population, which is 100% of the probability. So we use the symbol mu. So mu is a Greek symbol. Okay, so it's spelled as M-Y-U. So that is mu. It looks like letter U, but it has a line there on its side. And then for the variance of the discrete probability distribution, or sometimes we also use it to represent a the variance of the population, we use sigma squared. So this is the small caps of a sigma, because a capital letter of a sigma looks like this. So this is the small letter, small Greek letter. And since standard deviation is the square root of the variance, then we also use the symbol sigma. So with your familiarity with these symbols, you will now encounter the symbol mu, sigma squared, and sigma in computing for the mean, the variance, and the standard deviation of discrete probability distribution. So on the next video lesson, you will be learning about the mean, variance, and the standard deviation of a discrete probability distribution. So in here, I will be teaching you the techniques in solving in tabular form and then in algebraic method. So again, this is Sir Peter, your statistics and probability teacher.